Professor Arnob Kumar Laha, let me introduce him to you. He did his bachelor, master's, and doctoral studies in statistics at the Indian Statistical Institute and is a member of the faculty at Indian Institute of Management, Ahmedabad, for nearly 2 decades. He takes a keen interest in understanding how analytics, machine learning, and artificial intelligence can be leveraged to solve complex problems in business and society. His research deals with the creation of new methodologies for data analysis with a focus on non-Euclidean data, while his teaching interests include um, advanced data analytics, quality management, and risk modeling. He has published more than 25 papers in peer-reviewed international journals of repute and has served on the editorial boards of several international journals. He is the author of a popular book on analytics and is the editor of 2 book volumes on advanced analytics. He has served as a member of the governing council, academic council, committees of several reputed organizations and institutes. He has conducted a large number of open enrollment, blended learning, and customized executive education programs for IIM Ahmedabad and has undertaken consultancy work for many reputed organizations. He had featured among India's best business school professors, published by leading business magazines Business Today and Business India, and has been named as one of the 10 most prominent analytics academicians in India twice, and as one of the 20 most prominent analytics and data science academicians in India by Analytics India magazine. So we are really privileged and honored to have Professor Arnob Kumar Laha chair this session. So I will now ask Professor Laha to take charge of the dais, and I hope that Professor M.K. Tiwari is about to join. No? He hasn't yet joined. Please stay with us. Professor M.K. Tiwari, Director, NITIE, Mumbai, India, will be delivering the next plenary talk. Sorry, sir, we have to keep you waiting. Yeah, there's some link problem. Yes. Yeah, we've had some problems with this hybrid mode, some online problems we've had, but I think it's all part of this new experience of online offline combination. So please bear with us. We are trying to contact the speaker on the telephone. So Yeah, I'm told that he has joined.
Yeah, I'm joining. I'm joining.
Oh, Professor Tiwari, can you hear? Can
Yes,
you hear us?
I can hear. Can you see my slide, sir?
Yes, we can see a slide. Yes. Can you hear us clearly, sir?
Yes, sir. We can hear you, sir.
Okay, fine. I request Professor Laha to introduce the speaker.
So it is my pleasure to introduce Professor Manoj Kumar Tiwari. Professor Tiwari is currently the director at the National Institute of Industrial Engineering, Mumbai. And previously, he has been the professor in the Department of Industrial and Systems Engineering at the Indian Institute of Technology, Kharagpur, for a long period. He is a fellow of the National Academy of Sciences, India, and Indian National Academy of Engineering, and the Institute of Industrial and Systems Engineers, USA. He is actively involved in research relevant to the application of optimization, modeling, decision support systems, and data mining in logistics, supply chain management, and manufacturing research domains. He is associate or senior editor of several renowned international journals, including IJPR, BOMS, and so on. Professor Tiwari has led numerous projects and consultancy assignments with prominent industry and government organizations in India, including the Indian Air Force, Procter & Gamble, Tata Hitachi, and ports located in Eastern India. In addition, he aggressively engaged in collaborative research with partners from Loughborough University, UK, and Institute of Manufacturing at the University of Cambridge, UK, and the Warwick Manufacturing Group, UK, Durham University, UK, and the University of Connecticut, USA. Professor Tiwari is an author of more than 400 articles in leading international journals with an H index of 73. Professor Tiwari is well known among the operation research community in India and also has served previously as editor-in-chief of OpSearch, if I remember correctly. So welcome, Professor Tiwari. And
yeah, thank you, Professor Laha. I think I'm audible.
Yes, you are audible. Yeah.
So thank you, sir. In between, just I will trouble you because I will just ask you this kind of things because online slightly some hint is required whether things are visible or not. So my slide is visible, sir.
Your slide is visible. Yes.
Okay. Thank you, sir.
Regarding timing, 30 minutes plus 5 minutes for question and answer.
Okay, sir. Okay. Thank you, sir. Thank you, sir. Thank you. So actually, today I'm going to discuss an interesting topic for this particular conference, that how we can integrate ongoing two tough problems which are very much predominant in the industrial landscape. One is the prediction and optimization, and what are the analytics involved in the process. So before I say anything else, I wish to express my utmost respect and regard to the senior professors and organizers of the ORSI, which is founded by one of the famous statisticians, Professor Mahalanobis. And this society has served admirably well to the community of operational research, statistics, and now machine learning optimization community. And they have done wonderful job till now, and their flagship journal OpSearch, which we have been looking after for 3-4 years, that has also been serving well to the community. And this particular annual event of the ORSI is a remarkable one, and particularly those who are behind the scene, whose names you may cannot find. We respect them and we pay our utmost regard to them for organizing this and giving me an opportunity to express my just some analysis and talks points before the attendees of the conference. I'm sorry that we are using the mode of online, but because of paucity of time and travel, this we chosen, and thanks to that advisor that they permitted me to present it online. So combining the analytics, combining the prediction and optimization, this particular topic is born out of context because of the many online decision-making process, where some of them are sequential decision-making, some of them are parallel, and sometimes both we need actually to solve some of the complexities of the industry, particularly more predominant in the different domains of, say, for example, e-commerce, healthcare, financial issues, fintechs, and they are very much affecting the day-to-day life in decision-making. So that's why we chosen this topic for discussion. So you can find that they have plenty of applications of this prediction and optimization in the online market intelligence, where such an approach enables business through data-driven decision-making. And it is essential to club and integrate both the prediction and optimization. And we all know that most of the prediction to be done through the routes of advanced state and machine learning and AI, whereas optimization is traditional methods that we have to do either by the different kind of optimization routes like linear, integer, dynamic, goal, or stochastic programming. Whereas there are some newer algorithms which are random search in nature, they are also coming into picture to assist in carrying out the optimization related activities. So many of the real world use cases like how the advanced analytics in the fintech area, where most of the operations of that paying the amount to the partners, purchasing the things, smart contracts, and many other transactions which are financial transactions that are done through the technology, that is to be also that also needs plenty of prediction and optimization methodology to solve the problem. Then advanced analytics in anomaly detection. This is very interesting problem. I'm audible, sir?
Yes, you are audible. Yeah.
Okay, sir. So anomaly detection is very interesting problem, which are found in almost whether it's a bank with fraud detection, or you can find quality deviations and quality non-compliance in the manufacturing, delivery non-compliance in the supply chain, and also many of the online text analysis where we found that some of the missing concepts are there. So these anomaly detection is also another very interesting area where we found application of both. And e-logistic means where most of the purchase we do through either omni-channel or through e-commerce or through some online ordering systems. So they all are very popular and they need the mechanism of both optimization and predictions to solve some of the key challenging problems. And some of the actual cases we have listed here, like oil and sand producing plant, how they are using this prediction and optimization tools. So just in a glimpse, I will like to give you this broadness of this diagram, which is pertaining to supply chain operations, and how different kind of analytics and data needs, because nowadays we know very well, we call data is the food of all kind of analysis. Real-time analysis can be only done if there is a proper way to collect the data. So if you see a supply chain where more than 300 to 400 partners are there, say if you take the automobile or a car, at least more than 300 to 400 suppliers are there. More than 50, 60,000 parts are required. So for an annual operations, you can imagine the volume of the transactions that are taking place at different stages. So if you collect the data, say for example, right from raw material supplier to the supplier before the manufacturing, and then distributors, then logistics, means trucking, railway, roads, ships, etc. And then it goes to retailers, and from there to customers. So here, the data collection is to be done at different stages, most of by these kind of devices. Like sometimes we use readers, sometimes sensors, cameras, meter, robotic arm, QR code, RFID, portable PCs, panels, barcodes, they all used for data collections. Then second module in this case is the information sharing. It is to be done through the small base stations, IoT gateways. Then there are many other communication network, Wi-Fi access points, plates, which are being used to transmit the signals. And they are basically for information sharing. And moment information sharing is over, then we come to the data analytics stages actually. So under data analytics stages, if you see, first requirement is to clean the data, then integrate different kind of data and scenarios. And then sometimes we have to compress the data also. And then distributed computing model like file systems and, like how parallel processing need to be done. And then there is a fast storage, short-term storage, and long-term archival of the data that we want to do. And this also to be done through the cloud computing, storage and computing operations. And once this way, the process is completed like storage and computing things, then we start different kind of analytics. Like say how descriptive analytics work is very old one, where we have to use some inferencing mechanism, some logics are there. Then comes diagnostic analytics, where we have FMEA and all kind of other methods of diagnosis, where we find out the fault in the systems with help of some measures. Variance analysis techniques can also be like SOA, etc. They are to be used for diagnostic mechanisms. And then comes predictive analytics. Most of the machine learning applications like clustering, classification, and all other tools, they are being used here. And then prescriptive one, basically it leads towards whatever we predict here. And then based on those variables, we put them into some optimizer, and then whatever outcome comes, basically it combines both. So some AI applications, machine learning, and most of the optimization algorithms methods, they are used in the prescriptive analytics. So you can say that any kind of prediction, any kind of guess work or any kind of forecasting you do, ultimately we have to realize its impact in terms of cost or time or profit or something. So that need to be optimized considering different constraints. So that is why prescriptive analytics cover those things also. These are the different, I mentioned that ratios and kind of information sharing among them. So if you see the descriptive, basically hindsight things, and mostly informations are there that is to be captured and analyzed. And diagnostic, as I explained you earlier, that it requires some sort of finding out the diagnosis of the whole operation and process. Here prediction basically goes through different kind of AI/ML techniques, and then also many kind of regression methods also they are being used for predictions, and then prescriptive, as I explained you. So these are the different taglines which are connected with each one. Like say prescriptive, what should be done? Predictive basically refers what will happen next. Diagnostic means why did it happen, means reasoning, and then descriptive what has happened. So this way actually, and you can see the complexity. The moment you come to prescriptive, then it's highly complex, and value for analyzation gives more in this kind of thing. So the moment you combine the machine learning and optimization, then you can see some sort of correlation and some sort of description among the different elements. So you can see this is a three, you can say, broad leaf of the operations of combination of both. So here you can say many business rules are there, like through which we have where to apply. Then we have the business scalability, improve business and operations for the companies, and then optimize the recommendations that supports objective that gives better business understanding. So these are the different outcomes that we'll get by applying the optimization and machine learning. So optimization plus machine learning is equal to business rules. And these business rules are what they are. What we do in the optimization, certainly to obtain the best alternative from possible ones, maximize or minimize the real function by systematically choosing the input values. And here we apply all the machine learning and what you call techniques of the artificial intelligence. And basically it's a science, the programming of computers to improve the performance by learning from the data, both like training data and testing data, and then apply the tools. So here we noted down some of the, particularly what are the resource management professionals in the particular service industry, how they face this problem. So we have captured some of the points, like say resources are very critical, particularly service industry like say airlines, railways, or hospitals, banks. They are basically service industry, majority of them, insurance. And here goal is to find out an assignment of resources to different kind of jobs, which led to maximization of total matching score of the jobs and resources, so that we can satisfy the requirements of job within the availability of resources. These are very common kind of problem. And we have to defend it in many ways. So here you can say that machine learning addresses the scoring of the resources and jobs, but it alone cannot address the complex combinatorial where many alternatives are there with respect to assignment problem. And optimization addresses the complex combinatorial nature of the assignment problem, but alone it also requires a human to provide a large number of matching scores. And that's why making approach impractical and time consuming when solution space is really larger, means real time solution space means real operations, it's pretty long. Limitations as you can find poor demand fulfillment, lower level resource utilization, high project delivery cost, and then poor customer satisfaction. And when you integrate this, the prediction and optimization, you can see here we have to define the problem understanding, like what are the objectives, constraints, and key data parameters. And then based on this machine learning or AI algorithm or data engineering, like how to process the data by different, tools that are there in the Python and other languages. And from there, we use this particular thing to get the parameters which have been learned or which has been outcome of this machine learning. And also from here, what are the collected parameters by applying the different data science tools. And we put them into the optimization module so that some functions we can get maximized or minimized, like say profit need to be maximized, time need to be minimized, and stakeholders' interest need to be maximized. So like this, there are different optimization functions we have to point. And then these are the actionable decisions that need to be taken from optimization, maybe dispatching rules or maybe other things also. So as you can see that these two technologies, that is prediction and optimizations, can be leveraged together to bridge the gap between the machine learning and mathematical optimization tools. And then prediction and optimization can be seen both at the strategic level as well as the operational level decision-making process. And you can say we have to ensure that faster decision-making, online decision-making, that requires accurate prediction and then run a correct optimizers to recommend a proper decisions for given problems. So online market intelligence is another interesting area where many, that enables businesses through the data-driven decision-making approaches. So what we found here, like say customer-centric things are there, like say data-rich online portals, data extraction, data pattern matching and filtering, and then data modeling and maintenance, and coming to data monitoring and analytics. So in each one, what we give here is like say data-rich online portals like telecom, consumer goods, pharmaceuticals, restaurants, hostels, and many other external applications. Here we have a data extraction like reliable, accurate information, real-time insights collection, robust and scalable platforms are there. Here we do the configuring the business rules actually for standard methodologies, data pattern matching. And on the data modeling, we have to see the innovative results and insights, the practices implemented, flexible integration with ecosystems. Of course, then comes pricing of managers, product managers, market strategies. And then particularly field we are taking, say, travel and transport, retail, manufacturer, online marketplace, etc. These are the domain that you want to correlate with the market intelligence. Then the fusion or integration between the prediction and optimization, we need data, feature automatic transformation, logical transformation, then heterogeneous mixed learning prediction, and then predictive optimization, that is optimization. And finally, we build up some rules that helps us to build up the more autonomous or you can say intelligent decision making. So if you compare the old and new, conventional as well as predictive optimization, so here you can see The predictive optimization suggests that it's possible because of the utilization of the prediction results, which comes to drive the optimization issues and lead to the target indices. So all the variables which are there, the importance of variables and their relationship and actionable intelligence will be the outcome from this, and mostly supporting the autonomous intelligence generation systems. Then planned values are connected to the basis of tendencies in the predictive errors, and these values thus derive the outcome, particularly when we want to ensure the maximum effectiveness while avoiding the occurrence of the great loss. And these are the predictive optimization. Where a conventional one, we have the variables, and based on the constraints, we hope that it's sometimes impossible to solve the problems with large number of variables due to insufficiency of information, or even the target indices are present with more time-consuming parameters. And planned values are calculated without consideration of the predictive errors. And always there is danger that slight discrepancies will lead to the major loss. Then fintech area, if you see for real world use cases of the what do you call this integration of the prediction and optimization takes place, is a major benefit is decreased cost. So the moment you come to this, cutting the cost of budget building, say reduction in the reducing the prediction risk in investment banking, so that risk can be minimized. And here, cutting cost example, we have seen a case study where PwC, the second largest service network, helped a large financial institution to better predict daily cash flow and increase the return on payment activity. So these are the studies which are done by the PwC for organization. Then minimize the risk that overboard a Canadian startup that provides investment bankers and their clients with an AI quantitative analytics services. This helps eliminate human fallibility from the business of issuing, selling, and buying bonds. Then, if you consider the decreased fraud, that means fraud reduction, then here providing political risk signals for the hedge fund managers. So here the analysis says that a New York-based startup received $3.25 million in the venture capital to create platform for hedge fund managers to identify the potential political events which forecast their effects on a sensitive strategy. Then fraud preventions, basically this is the data visor is one of the fraud detection engine that can accurately assess the likelihood of fraud across a range of the transactions. And then managing credit card default risk, that is data robots, AI or cloud platforms allows the Carbon like a digital bank for undeserved African market to automatically assess the credit worthiness of individual customers. And then optimizing customer journeys, like say Teradata Vantage is an intelligent multi-cloud data platform that streamlines the data analytics for large enterprises. So if you see here, prediction and optimization or portfolio optimization, which is a very important topic in the finance and other areas. So historical asset and stock data is there. From here, there is technical indicators and lagged observations. Then we apply the different machine learning algorithms like say LSTM, XGBoost, AdaBoost, etc. And from here, we predict the stock. And then we apply the alpha model or risk model, and then come to the portfolio construction. And on this side, the portfolio optimization done by the portfolio evaluation, and then mean variance portfolio optimization model is to be done. And finally, both the models lead to here, and that way we can decide what is the best portfolio for solving the problems. And then advanced analytics, as you can see from both the requirements of prediction and optimization, is the anomaly detection. It has massive use in the banking, like say Danske Bank majorly used. I know one of my students was very good, who was part of earlier Scotland Bank, now merged with the some other bank, but primarily he's in the one of the bank in Singapore. His main job is only to build different products for the anomaly detection in the transactions. Actually. Then many of the consumer product goods, like, who are dealing with the like day-to-day using brands like washing machine, powders, soaps, shampoos, or many other kind of devices. So are used items. So they actually use fractal analytics that we have found out from one of their clients, the CPG firm that use anomaly detection for demand planning to estimate the better forecast. This is a very interesting area because such industry where you can save a lot by having better demand planning. Though it is good for any other industry also, but here it helps a lot. Here bulk purchasing is done by the many industries. Telecom industry like say Geek Minds help a Fortune 500 company to fix issues in their Syrian network and improve the customer satisfaction using anomaly detection. In healthcare industry, the National Library of Medicine, Grand National Science Foundation uses anomaly detection, as a potential tool for the spotting the abnormal events that could indicate a medical error or unexpected clinical effects. So here we have a model 1 training data, and here like say historical data, sensor data, then network topology. Then we go for network data aggregation, and then we perform dimensionality reduction through autoencoder, and then training of the machine learning problem. Once it is trained, then come to the historical network sensor data, then network topology, and then apply the model 1 to get anomaly predicted level of each node, and then network pre-screening, and finally optimization initialization is to be done, and that will leading to the solving the optimization problem. And here anomalous segments for the entire network is also known. Then comes the e-logistic area where both have a massive applications. So before I go, I just want to ask the Arnagia and to chairing a session. Am I audible, sir?
Yes, you are audible. Yes.
Okay, sir. Then for online distribution and network where we use both the techniques, they are for basically customer demand, candidate facility locations, current facility identifications, and these are very well demanded problems through which we can minimize the distance which the sales volumes used to travel by having different kind of SKUs in the cities. Then current centralized facility network, which requires more strengthening. And then company objective is that one-day delivery. Normally this rebuild the centralized facility network into a very coherent, interconnected, multi-level network organizations. And as you can see that many of the other tools for e-logistics which are used for prediction optimization, like say demand factor sensitivity analysis, where you use the ANN model, correct? The neural network model is there for that, and then ANN demand predictions that we use. And finally, the demand distribution, e-logistic quality, purchasing power, they all are required for as input to the ANN model. And this can come from the historical data transaction, logistics log files, demographic statistics, and then finally we use the demand predictor. And from here, actually, data goes to the optimization module, where we have primary facility locations, and that is being used by the ENM algorithmically. So secondary facilities, in logistics services, quality-related issues that may come here, and then updated demand distributions. From here, it goes to the hierarchical customer aggregation, and that's why we are able to have initial demand distribution process. And then while closing, we have to for earning, setup cost, packaging, process cost, package process cost, and profit design and evaluation. Correct? Then here we have seen that case by this kind of thing, if the 6-hour shipping, 24-hour shipping, like this 24-hour shipping, this is the 6-hour shipping curve between the time delivery time and demand. There is number of packages. Then you can see that how they vary over the delivery time. Here actually we are talking there a particular industry which is dealing with oil sand producing plant, how they are using both prediction and optimization tools. So we have a site-wide lead actually, So site-wide lead log data. And then we have a process information, weather information, and all the details here. So based on that, actually, first oil sands and oil and tonnage, different grades they require for mining. And then primary extractions like both bitumen, import, total froth, and then secondary extraction like diluted bitumen, and last one synthetic crude oil. So these are the different tools which are there on this side. And then the moment you go to structure, the YAML technique for process prediction, and this is the regression-based optimization actually. And finally, recommendation on flows, like set up the points to optimize through throughput, and optimal recovery plan, and scenario analysis for various operating conditions. In operational set point recommendations to continuously improve the site-wide operations are apply the sensors data of an oil producing plant, and then use the machine learning model to continuously learn the behavior of all the subsystems, and then go to optimization module where advisory control to near real-time data is provided. And you can see solution has been deployed in this industry and estimate to generate business volume in order of tens of the billions of dollars per year can be saved by this process actually. So this is where how I wanted to cover. So now I request the chair to have some questions. If it is there, we should try to answer.
Thank you, Professor Tiwari, for a very interesting and illuminating talk. So if there are questions from the audience, you can just raise your hand and we can ask. Any questions? No questions? So thank you, Professor Tiwari. There doesn't seem to be a question from the audience. So thank you very much for your time and joining this conference online. Wish you a very happy new year. And
thank you, sir. Thank you very much.
Thank you. All the best. Thank you.
Thank you.
Well, we thank Professor Tiwari for his participation. And now we also thank Professor Arnob Kumar Laha for chairing this session. Yes, yeah, please be seated. Professor Laha for chairing this session, and he continues to chair this. And the next plenary talk is going to be by Professor Tayyeb Melouli, Martin Luther University, Halle-Wittenberg, Germany. So I think Professor Melouli has already joined. Yes. So I will ask Professor Laha to introduce him. Thanks.
Thank you.
It is my pleasure to welcome Professor Melouli online to Kolkata, a city in the eastern part of India. So Professor Melouli did his high school diploma in Tunisia and studied parallelly computer science and mathematics till 1990 at the University of Stuttgart in Germany, and then got his doctoral and postdoctoral degree from the University of Paderborn. In this connection, he switched in 1995 from theoretical subjects related to automated reasoning in logic to more practice-related works related to logistics, especially routing and scheduling in public transport systems, yet with strong mathematical optimization background. Anyone who stays in Kolkata would appreciate the importance of this work. After a practice phase at TUI-FLY, Hapag-Lloyd in Hanover, where Professor Melouli initiated the development of the currently productive crew optimizer system, he switched in 2004 to academia as a professor for business information systems and operations research at the Martin Luther University, Halle-Wittenberg, and collaborated ever since with selected practice partners, especially airlines and thereafter hospitals, seeking IT and decision support for their complexly structured decision problems. Dealing with business case studies in complex systems with inherent interdependencies in their decisions, a current research interest is to develop generic methodologies for interdependence-aware modeling, analytics, and optimization with high scientific and practical impact. Professor Maloli also maintains his former interest on knowledge-based systems, and by investigating AI-OR synergies, develops insights and innovations to develop mutually interacting decision-making, decision support systems for experts. So as you can see, he is a great scholar in this field, and I welcome him for his talk. Over to you, Professor Maloli.
Yeah, thank you very much. Do you hear me?
Yes, yes, we can hear you clearly.
Very nice. Okay. Do you see the mouse on? Yes, on the.
Yeah.
So
Perfect.
thank you very much for the introduction, and thank you also to Smarajit Khan, Professor Smarajit Khan, for the invitation. So I would like to speak about interdependence awareness, which I found very nice new research direction to understand complex systems and the business in these complex systems. So, and the range of modeling, analytics, and optimization for these things. So, if you would like, please, the camera on some persons to see some persons, not if it's possible. So the motivation is for the systems point of view. So Greg Stoll, Harvard Business Review, say optimizing each part of the firm doesn't optimize the whole firm. An organization's trap is to looking at isolated metrics but failing to see the whole system. Optimizing each part of the business and failing to consider how they interact. And the manager trap, he said, by improving each part of the enterprise, the whole would be improved. But the observation is when we see an operation as a set of metrics to optimize, we lose our sense of context and decrease overall performance. He says an efficiency paradox. The world is so far too complex to be reduced to Excel sheets, organization charts, etc. And what really important are the nodes, not the nodes, but the network. So what I mean, interdependence is everywhere between elements, components of real-world systems. And this both on production process, on business operations level and business management of a firm, level of production process, functionality in manufacturing system, also in higher levels of decision makers in operations management. So what is needed is independence awareness in modeling, analytics, optimization. There are two interesting aspects. One is business side, recognizing the interdependencies relevant for decisions. And the other side is independence aware decision support using all the tools we have, optimization, simulation, etc., and artificial intelligence. So I give you a short example from a textbook to see independence awareness matters. I take a case study of multi-period production model with fixed plan for machine maintenance from the book Williams. A very nice book for model building and mathematical programming. So the optimal gain of this multi-period problem was $93,000. So the extension of this case studies, he says, integration of machine maintenance into multi-periodic period. So one sees some of interdependence between capacities of machines and capacities of resources. and then to say, okay, the machines are maintained, so you don't have it for production. And one nice idea is to optimize the production model together with the maintenance of machines. And the optimal gain was 108,000. That means 16% additional gain. This is great. This is very great to see only one interdependence between two things in reality and gain more than 10%. So this is not something which is only on business level. I can show you that this problem is on decision makers level, because you have something like that. You have a technical department where machine maintenance is done, and you have production department where optimization for production is done, and the technical department schedule the machine maintenance without regarding the production. So they give a fixed plan for machine maintenance. The better way around is to make a negotiation between these two decision makers and to say, hey, I don't want to have a fixed plan. I want the rules for governing maintenance. And the production department should optimize his plan together with an optimized machine maintenance, and the gain is again more than 10%. This is very great. So this is independence awareness. So and the second thing in my talk is complex production systems. What does it mean? I go through a tour through my department's main research projects, including these complex systems, involving complex business environments, involving complex activity structures, intertwined flows of patients, of crews, etc. So we will see that involving complex activity structures and involving also human beings as customer side or resource side. So I will consider in this talk some of modeling, analytics, etc., artificial intelligence, learning, simulation, all of these things together in a hospital patient flow management. This is a complex system with complex environment, and we ask what are the ingredients of these complex systems, how to analyze and characterize main complexities in the system, and why interdependencies of decision play a central role, and how to combine solution methods for effective and efficient decision support by, for example, AI and or synergies like my former presenter who used machine learning and optimization. But the talk also gives a new way of seeing things, complex things. So a new framework to independence-aware modeling analytics. This is a two-dimensional aggregation scheme with respect to complexity dimensions, with aggregation levels, and you have a generic hints, including methods of choice, advanced OR or AI or R synergy. Let us see what the classical way of doing things is modeling and then using solution methods to solve problems in OR. So you have something like a model, like here, supply and demand in transportation problem. So you have a mathematical model, you solve it. So another person, Fuller and Martins in Journal of Business says, operations research and operations management from selective optimization to system optimization. He says there is the modular trap, assuming a simplistic attitude about planning process, or not acknowledging the process at all, or acknowledging not only one aspect and not acknowledging the whole process. He says, okay, suggestion is there is a poor modeling by unrealistic, oversimplified, or under-perceived constraints. And he says incorporate OM, OR models. This is nice. The this survey is on operations research, which is on the mathematical model side, showing good applications and operations management, having the practical side and seeing to the formal models. This is very nice. And he says incorporating these two art of models or types of models and their output into decision-making structure of the organization towards the goal of system optimization. But it is not sufficient to have integration of IT, integration of communication, etc. You saw this in the problem of maintenance, technical department and production department. They interact within information system, but we need something else. We need thinking about the decisions, about the interdependence between the decisions, and then have integrated optimization models. This is one way to do it. So let us look. There are also in textbook modeling advanced aspects like robustness against uncertain complex business regulation, etc. There are also tools in methods, but it seems to be not enough to manage complex systems. And I want to show you how possibilities, how to do it. So let us look at some complex systems. Two main projects I have since 20 years, airline crew management with productivity level, maturity, and since 10 years, I have research projects with patient flow management with the University Klinikum Halle in Germany here. And we have the data of 40,000 patients and treatments. And both projects have complex environments, so airlines and hospitals, and especially the management of business processes. We have flows of crews or of patients. Crew flow management, so you have a flight plan and you optimize the schedules of the pilots, etc. And from the other side, you have also here a hospital with several units, and you have patient pathways who makes the flow in this. What makes the flow here? We have a new idea to take. Okay, pairings are such sequences of work and overnighting, and we extended it to chains. So you have also here some kind of flow. So the crew pairing chain. This is a new name. So I will speak only about patient flow management, but these two complex systems gave me insight where are the dimensions of complexities. To show you the picture. So we have a hospital patient flow. Basically, we have two things. One is the complex environment, shared resources, compliance, complex organization conditions of the hospital. From the other side, these complex structures of patient pathways across many wards using multiple resources. And if we look at the details, so the evil is in it. Activities are organized in complex structures, pairings or pathways. Flights are connected to duties, then to pairings, then to pairing chains. Treatments are organized in clinical pathways. And then you have another kind of complexity. So you have not only one, you have several ones, several crew members, several patients who makes the flow. You have the flow of crew or the flow of patients. Sometimes it is at resource side, the complexity of the crew. And in some problems you have it in the demand side in the flow of patients. What else? We have a cross of complexities for management of a complex business. You have the crew flow through the time-space flight activities to be covered by the crew, and you have patient flows through also time-space hospital wards, providing service also to be covered by the physicians, etc., in the wards. So what we have, so if we see the structures, what we have is many complexities. One complexity is the internal composition of activity structures, who makes the patient pathway and who makes the pairings. You have another problem, the flow. The flow can be seen as a multiplicity of activity structure, not the internal composition, but the many ones which you see here, the many ones through the hospitals. They should be covered together at the same time, at the same day. And you have for the flow management problem, you have demand and supply sides. So in the first design of the complexities, we said we have a problem of demand side and supply side dimensions of complexities, but really it is better to see that we have internal composition and multiplicity of activity structures. So what can we do? So we take a little bit, so we have the hospital from one side and patients on the other side, and we have this complexity of activity structures. Patient pathways in their composition are complex and the flows are complex. From the other side, we have a complexity of wards structure or department structure with interdependencies between them, and we have a meet between them. And there is some kind of, so you should cover something, so you have less or equal between the flows and the ward capacities. Yes, the resource capacities and the flows. But you have also here the complexity that you have a complex structure and complex flows. So what to do? We need more than this picture in perhaps classical textbooks. So we need the business side analytics in the general sense of the word. So a deep analysis of reality problem. So we have to understand the source of complexities. We have to make deep analysis of business side. We have to go away from unrealistic to realistic modeling, from under-perceived to perceived constraints from overall process. So and the methods will be also have to be extended. But let's have a look of this. What can we do to see the complexity? So one way is what I say termed as hypothetical complexity. So we suppress one source of complexity and see and analyze the other. So like this, you have composition and multiplicity of flow. So let us take out composition and assume that patient treatments are only one treatment or one treatment bundle to be served by a single ward, and to see what happens for patient flows and hospital wards. This is principally the modeling of this with this simple idea to say, okay, you have a bundle of demand, patient treatments and service wards. And there are, if you go into the detail, so you find many hospitals or working or specialized physician here or specialized outpatient clinic, and also some clinics which are decomposed in patient flows. So you don't need some optimization because the flows are associated to a unique word. So you don't have a problem of optimization of the flow, so you can decompose your problem to many departments, and many scientific work make simulation optimization for one department in a hospital and make simulation in one hospital. But we say we have to look at the whole hospital because not of this, because of this structure. Let us say, okay, there is some disadvantages of this, since if the capacity of the department is overrun, so you have to reject some patients, and this is not nice for the gain. So you have to delay some people. So and in our opinion, this structure, we have it found in the University Hospital of Halle Saale here in Germany. The patient a priori, and here you cannot a priori make a decomposition of patient flows to the wards, and patient flows can be directed to several wards. So you can decide, you can optimize, you can make some kind of shifts, yes. And some example is treatment blood vessels and heart diseases can be served by heart department, but heart diseases only by heart department. There are rules of dispatching, and we found it is have several advantages. Yes, some people say, many managers say, clustering, separated department is better, but we see this disadvantages of rejection. But we saw here that it is possible in this kind of complex dispatching to make some kind of redirecting of patients to other departments, saving this patients which are rejected in the other case. And you can also make some kind of service shifts from the resource side, etc. So you see, also I have assumed only one complexity side. So I took out one complexity. The problem is very complex. So you have a structure, dependency structure of the words. You have some kind of cluster, but in our research we found there are not really a cluster, but there are some kind of quasi cluster. There is a problem of emergency patients, stochastic and elective patients, which are planned. We have experiments real world with yearly data. So let us go to the detail of both sides. So we want to also include methods, advanced OR, such as hierarchical optimization, system-wide simulation, AI, and OR synergy. And we want to have also a generic tool where you see the complexities. And this one, I hope we found one which is very beneficial for operations researcher. So let us look at this. So we saw in earlier slides that we have from one side a pathway composition. So the composition of, so you have here some treatments, and they are here in individual paths. And from the other side, you have the hospital environment with one word and many words and hospital-wide. So you have two dimensions of complexities. So you hear me very good? Yes. Yes. Okay. Thank you. So and we wanted to see this kind of complex hospital decision making and decision support tasks, how they can be better organized, better characterized, where we see better see the interdependencies to be interdependence aware in our modeling, and we started in this way. So we say, okay, there are many many problems, different problems. In one word, there are simpler than in many words. If they are connected, as I said earlier. And the problem here in the overall hospital wide, it's another thing. So you have all kind of uncertainties, all kind of disturbances, etc. And from the other side, we can choose to see the level of aggregated level, weeks and months in advance, also strategic, tactical, and operational, if you want. Here, a treatments level with individual paths, here beds in wards, etc. And here only treatment types and services. This is nice. So we have also both sides. Both sides are here, not only the activity, but you can see, okay, this dimension have to do with supply, with demand, mainly have to do with demand, and this have to do with supply, because supply is given by resources, by environment, but in reality, and this is the new, as you want to say, it is a further development of our new two-dimensional aggregation scheme, to see there are both supply and demand complexities in this. So you can see here the composition of pathways and multiplicity of pathways. And from the resource side, we see here the detail consideration of the resources, function-wise or something like that, or day-wise or treatment-wise, or the resource in its extent, in wards, in many wards, in hospital-wise, etc. So you have two things, and the complexity, so demand and supply are in both complexity level, and they have to meet for managing problems. So the management problems are in a way of the art, demand must be covered by supply. So and you have here two kind of aggregation levels, of detail level, to see here the problems. So this is only now the two dimensions, yes, but we didn't see yet the two-dimensional scheme. So let us say, okay, we have this kind of, okay, let us say, okay, our goal is to have a hospital-wide planning. The hospital-wide planning is done when you consider all patient flows with and all detailed resources. So this is the main goal here. So the main goal is to have a hospital-wide planning. And if you look at Cowor's grain, you see here the beds, the overall bed management. And if you see here in a aggregated level, you see the starting points. The starting point. So you see that there are connections between strategic KPIs analysis and medical point of views of diagnosis-based resource estimation of one patient flow of one patient case, yes, and the overall hospital management. So you can describe them in the same two-dimensional scheme. So what we want to have is a way to go from this strategic analysis to the operational planning, detailed optimization, yes, of businesses. So you can go at this way or another way around, and we will now look at the possibilities. So let me say here there are homogeneous flows. If you consider one word, and if you consider many words, you have many types of flows of patients, yes, and you have some kind of multi-commodity flow problem. Here you have only a single commodity flow problem. So you have to make some kind of advanced operations research here. So we go to the methods. So it is an opportunity here to see this kind of things. So let us look at here. So you can now think about the problems here. So you see one word, many words, and the aggregated level, what kind of problems here. So this kind of scheme helps you to see problems which were not apparent for you in the analysis. So we see here the capacity planning, demand forecasting at one word level, at many words level, and the patient mix optimization have to do with these things. And it helps you to go from this to this. And here performance analysis for the hospital, here hospital-wide, etc. And you can go also the other way around. The other way around is also very interesting. So you have here a single pathway. This is a nice one. The first quadrant here is a little bit coming from research. What is so what is less than one word is one people. One people is an abstract level. So one single pathway. It is very nice, this point here. So we can think about the types of things. Yes, the types of pathways, how they are structured in an abstract sense. Yes, so we see how a diagnosis is related to the treatment, to the patient pathway. So we can make here pathway mining. So you can include artificial intelligence and learning, and we can use here artificial data science, statistics, and here simulation, and we can have here AI and learning of complex structures. We can also use good distributions to make a simulation on a hospital-wide level. We can advance here to what we see it later. So let us look at the complexities, how to solve them. So now the evil is in the detail, but the angles in us coming out now for the methods to tackle these complexities. So this is data science for comprehending the composition of activity structures, and from the other way OR techniques, yes, to advance OR techniques to, and there is also a new thing. There is a harmony here between artificial intelligence and learning and operations research. So let us look at the whole picture. So you have here advanced OR. We said that for one word you have a homogeneous flow problem, and here a multi-commodity flow problem, because you have many words and many types of people. So this is the whole picture. So if I have time, I would like to show you some results of these two possibilities of methodologies. One is a classical one, and one is a more advanced one. So let us look at our architecture. You see here also in the architecture that we have a synergy between descriptive, predictive analytics and optimization simulation. So predictive, prescriptive analytics. We have synergy between data science, AI learning, and operations research. So let us look at the one case study. Actual pathways from through hospitals. So you have 40,000 patients pathways for 1 year. So you can make good distributions of model parameters. Better input gives better output. Let us look at this simple case. How does simulation work? So I don't like to go into the detail here. So you have the problem of emergency patients with this stochastic thing. So you have here emergency department. and you have here the words, and you can switch the word, relocate from word to another word to take advantage of this service shift. So we in our first analysis of flows and words, we saw that there are many advantages that many words can share some types of patients. Yes. Because if you have no capacity at one word, you can switch to another word and not do rejections. So this is very important. So to have this kind of strategical moves, yes, which we can do in planning, in operations. So a hospital with shared capacities is better than a hospital with non-shared capacity and non-sharing functions. So as we saw in this study. So first we take the validation that the difference, and then we have some simple scenarios to see this gain, to use the capacities of other words, neighboring words, or neighboring in a expertise sense. Yes. So we decreased significantly the waiting time, and we have savings of 10%. So also in this case of waiting times. So the distribution, the peaks are the number of waiting rejected patients decreased significantly. Performance depends on the evaluated cluster and configuration. So, and you saw. So let us came a look of more research oriented. Both are research oriented, because the first was hospital-wide simulation and not simulation of one word. This we have the pathways, associations to the diagnosis. We have the pathway composition. So how to learn the pathways, the clustered pathways results in pathway composition to each pathology or diagnosis, and pathway routes through words, and then to use it in a advanced optimization. So we have a problem of a jungle of pathways in a hospital. So what to do? Many illnesses, many paths, and we want to find this nice types of patient types. But really, if you take from textbooks or from research work some kind like process mining, or so we it is an illusion. So what we learned is something like spaghetti. So you have tens and perhaps hundreds of types, not of single pathways, so of pathway types. So and we cannot work with them. So we need something better. Why and what to do? We need some structuring and conception about what we learn and for which goal. So we have to think. So we want to learn for optimization, and optimization needs the flexibilities. The flexibilities in the pathways, I need them in the optimization. So and the spaghetti of the pathways is not good for making good optimization and efficient optimization. So we thought about to see the pathways types as some kind of DEG structure, directed acyclic graphs with two levels, bed level and treatment level, and then and we should find this nice types of graphs. And we took this as input for or we make clinical pathway mining to enable scheduling. So we have a goal, and what kind of suggestion. So learn business relevant aspects and not all. Only as much as necessary of the complex activity structure. So for your next step, so if we take this and also use a very advanced optimization here, a data-driven hierarchical mixed integer programming, have a decomposition of hospital-wide planning to a detailed planning at wards level. So you see here we got many nice results here from the operating room, which are smoothed here in the planning operating room. So here the state, to be state is better. No, you see it is green and streamlined, and we got so the pathway structure. Oh, this picture should go before this, because we don't learn pathway sequences, but we learned the activities within the treatment path, and we learned some kind of precedence relations. So it is like a digraph. We wanted to have perhaps 40 or 50 types of patient pathways in one network, with constraint structure, and this kind of constraints and precedence constraints can be integrated in a mathematical model. So I go to the conclusion. I hope the time is okay. Classical modeling, analytics, optimization techniques, also of advanced textbooks, seems to be not sufficient to efficiently manage business in complex real-world systems. So this is my observation after 10 years of research in hospitals and 20 years for airline. So it is, there is all, something is missing. So my perception. So there are hierarchical optimization, yes, vertical, horizontal, very nice, but to see the whole picture, I think this two-dimensional scheme is a generic meta level good help for operations researcher to look at their complex systems in reality, and don't only have a toy model for some aspects of reality, or to make many assumptions to go into a model frame which is known in textbooks. No, you have to consider the complex real problem, and you have to make a deep analysis on the business side to see what are the dependencies, like the study before the two. Now the study of the flows and the capacities make me aware of the problem of rejection, which could be reduced if I have shared functions in words. So you have to make a deep analysis of the complex system. Each complex system have other complexities. I don't know, but I think you always can make this 2 dimensions with aggregation levels. It is one new methods in our department, a 2-dimensional aggregation scheme to support business side and methodology side. So advanced operations research opportunity, harmony between artificial intelligence learning and optimization. You see it in the 2-dimensional scheme. We showed advanced optimization and simulation techniques to deal with multi-ward, hospital-wide management, not only small studies or study of some aspects or some departments. No, we want to see the big picture. Optimizing a system should look at the interactions between the components more. than optimizing the single component. Since at the motivation level, I said optimizing each part doesn't optimize the system. And the problem of technical side and planning side, if we look at the metric of maintenance planning, you look at your workers and not on the production. So this is the problem. So you have to look at the whole process and at the whole metric, not at the single matrix. So and RE/OR synergetic hybrid method. So you have also 2 papers on this if you want, 2-dimensional scheme and RE/OR synergies in hospitals. So if you like, so I give you references. So with proven benefits for complex systems business, both in airlines and hospitals. So I hope you have some idea how this new direction nice. I find it nice. So I hope you you found is also in this way. Thank you very much for your attention. So in German, vielen Dank für Ihre Aufmerksamkeit.
Well, thank you, Professor Maulali, for a very interesting talk, focusing our attention on complex systems and the importance of using multiple techniques to be able to get to good decisions. Any questions from the floor for Professor Maulali? Please raise your hand and you can ask your question. It seems there is no question from the floor. So thank you, Professor Maulali, for your interesting talk and enlightening us.
So do you have a question?
So as I looked, yeah, please. There is one question.
Yeah, it's very
Come
nice.
here and ask. Yeah.
Sir. Sorry.
Professor, centralized and decentralized mainly services.
What do you want to say?
Centralized and decentralized services. Your
Centralized and decentralized services.
decentralized services are involved in your process. Is
Yes.
it? Then it say something may be convenient for the management, may not be convenient for the customers, the patients, but some may be again convenient for the patient, but it may cost more for the management. Which one you give the importance and how you do the optimize?
Okay, thank you very much for this nice question. So I have, as I say, 20 years of experience with consulting airlines. So TUI Fly, or it's known Hapag-Lloyd, former Hapag-Lloyd. So we had discussions with crew personnel, and they want always some rules to be that they are happy, etc. And from the planning department side, they say, "Oh, we cannot approve this." So very one problem which I want to discuss with TUI Fly in the next weeks. So they changed the home bases, and the crew should go from one home base to another with the proceeding with the train or with the Lufthansa or something like that. And if the rules say the rules now say it is not allowed to go more than 4 hours or 4.5 hours by train to proceed to your flight. So and as the home bases after Corona have decreased the number, so there are impossible ways from I don't know, Hanover to Munich. So we have to make both sides, business side and so the firm side and the client side. So there is a three points rectangle. So we have to make a compromise. And I say in my consulting always in these groups of discussions, so what is good for the firm is good for the is also good for the crew personnel if we find good compromises, if we find good ways to make a solution. Yes, there is a problem. So if you make it centralized, dictator ship from the center, and it doesn't go. But you have to weigh the things. You have to make discussions with the folk, so and go to good solutions. I think that centralized production does go only for some production. So this is by chance airplanes are centralized maintenance, no, because the airplane is the center and you make no, but the production is better in this decentralized way. And there are new aspects like cell management, not job shop or no, cell formation problem, or new things like micro factory, etc. So there and in management, virtual organization made by many worldwide departments. So you have to work in small departments, but you have to see the whole picture. You have to see the overall processes should be efficient, and this is not simple. Yes, it is not simple. If you make it in a wrong way, you have the clutch, which you say centralized things are bad for the people or bad for the client. So this is, but I think this slide, this talk show, we have to deal with complex systems. I am not to say, okay, like the direction of many communicating IoT, etc. It is different. Communication, IT is one field, and optimization and decision support and operations research is another field. So we, the operation researcher, give insight to the IT what is better, not the other way around. So if you think, okay, the best thing now is IoT, etc., and autonomous object, etc., autonomous, but in decisions we have to have an overall outcome, and you cannot let departments work in autonomous way. So this is my my opinion on this.
Okay, thank you.
So thank you, Professor Mullally. Another important aspect, I believe, is to examine disruption in complex systems.
Yes.
As we have seen in the COVID-19 pandemic, a major disruption in complex systems can have a huge impact, not only for a short period, but a lingering impact for multiple years, as we are seeing in many spheres of our activities even now. So I think we need to study these kind of systems more carefully, and I think new principles needs to be developed to be able to get to what you are saying just now, that what amount of centralization is optimal for complex systems. So thank you for your very nice talk and your thought-provoking.
Yes, only one remark. The management of a complex system doesn't mean centralized management. It does mean that all the departments should look at the optimization of the system. So it can be from the bottom. It should not go from a manager from the top. It is only to see the overall process of production and to make the processes as efficient as possible in the system-wise view.
Absolutely. Thank you. Thank you so much for your thoughtful comments. So let me thank you for this.
Thank you for inviting me, Mr. Professor Khan, and goodbye.
Okay, thanks for your participation, and we also thank Professor Onno Kumar Laha for conducting this session as the session chair. And yes, we appreciate your participation. And as a mark of our participation, as a mark of our appreciation of your participation, we would like to offer you a small gift, a small memento. And I request Professor Samarjit Kaur, the program chair, to give the memento to Professor Laha. Well, thank you all for your participation in these sessions. We come to the end of technical session 4 on the second day of this OLAP 2022 International Conference. And now the paper presentation sessions 3 will start in the 6th floor of the ICT building, which is the next building to the south of this building. Cultural program will be at 7 o'clock at this auditorium. 612, acha, এটা 612 আপনি কি কারোর সঙ্গে যেতে পারবেন? আচ্ছা আমি আচ্ছা চলুন আমি আপনাকে ওখানে দিয়ে okay, once again, technical session 3, the comes to an end, and then we have further proceedings in the ICT building, the building next to this, 6th floor, ICT 612, 613, 614. Paper presentation sessions for you all. Is that clear? Yes, yes. Yeah, we are waiting for a technician. He is, yeah. So, is there anyone still here? Oh, okay. Oh, okay. Yeah. Professor Meluli, yeah.
Yes.
Yeah, okay. So, yeah, we have come to the end of the session. Yeah, thanks.
Yes,
thanks for visiting Calcutta. Thanks for visiting Calcutta online.
you are Mr. Khan, yes?
No, Professor Samarjit Kaur is just left this auditorium.
Okay, many greetings to him. Yes, okay.
Okay, sure. I'll convey that to him. Yes, thanks.
Okay.
Goodbye.
Goodbye.
Yeah.
How get out here? Oh, I don't know how to go out here. So.
Oh, okay.
So I found I have to find the Zoom. So Zoom verlassen. Okay. Goodbye. Goodbye.
Goodbye, sir. Goodbye. Yes.